Alright guys, I hope you're enjoying the ARKit tutorial so far, because we are going to embark on creating yet another really awesome ARKit app. So the first thing that we're going to do is create a brand new Xcode project. And of course, we are going to choose the augmented reality app template. Hit next, and I'm just going to call mine AR Ruler, because that's what we're making. Feel free to call yours whatever you like. Alright, so here's our brand new ARKit project. And the first thing I'm going to do is delete the unnecessary template code that Apple gave us. So I'm going to get rid of all 3 lines here and just leave sceneview.delegate itself. And then if you scroll down to the bottom, I'm going to delete all of these delegate methods and also the did receive memory warning method. Alright, so that makes our view a little bit cleaner and easier to work with. Alright, so the next thing I'm going to do is I'm going to add some debug options. So I'm going to say sceneview.debug options equals AR scene debug options, and I'm going to go for the one that just shows the feature points, because we're going to be using the automatically detected feature points to figure out which parts of the scene are a continuous surface and be able to measure something on that surface. Alright, so once we've done that, the next thing we need to do is to detect user touch on the screen. So we're going to use the method touches began, and we're simply going to print the console that a touch was detected. So you can pause the video now and try and give it a go. So there's nothing new here. You've done this in the last tutorial. So why don't you give it a go and see if you can do it yourself. Alright, so hope that wasn't too difficult. We're going to head below, view will disappear, and we're simply going to start typing touches began to search for the one that we want. So this is the method that tells the object, and the object is obviously our view controller here, that one or more new touches occurred in a view or window. So exactly what we want. Now inside here where it says code, we're going to print to the console and say touch detected. Alright, let's give it a spin. So the crazy thing is actually you can make this endless hallway illusion. Alright, enough playing around. Let's have a look. So we've got our feature points detected on screen, and if I tap anywhere on the screen, you'll see touches detected showing up. Perfect. Alright, so now that we know that our code for detecting touch is working, we're going to grab the location of the touch on the 2D screen. So instead of printing to the console, I'm just going to delete that. I'm going to use optional binding to grab hold of the location of the touch. So I'm going to say if let touch location equals touches. So this is that set of UI touches that we get back whenever a user touches the screen. So in this set of touches, I'm going to grab the first one, if it exists, and then I'm going to check for its location inside the scene view. Now, if that succeeds, then we have this object touch location, and I'm going to perform a hit test using that touch location and see if it corresponds to a feature point. So I'm going to write let hit test result equal scene view dot hit test, and the point is going to be the touch location, which is a CG point, as you can see, and the type is going to be a dot feature point. So as Xcode explains, the dot feature point result type is a point automatically identified by ARKit as a part of a continuous surface, but without a corresponding anchor. So we're not interested here in detecting planes or going into the plane anchors or 3D anchors. We're actually just interested in using the code inside ARKit to detect continuous surfaces. And this will give us the 3D location of a continuous surface that I'm tapping on, if it exists. So go ahead and hit enter. So now we have this hit test result object that we can work with. Now what I want to do is to use this hit test result, which is a location in 3D space inside the real world that's on our scene. And I want to add a simple red dot to that location. So I'm going to say if let hit result equals hit test result. So you can see that hit test results are actually an array of hit test results. So we can actually change that to results, which might make it more understandable semantically. So if let hit result equals hit test results dot first, so grabbing that first object in that array, and if that exists, i.e. this is not nil, then we're going to call a function called add dot to add a dot to the scene, basically. And we're going to specify a location, which is going to be the location of the hit test result. So of course Xcode is going to complain because I don't have this method called add dot yet. It has no idea what I'm talking about. So I'm going to go ahead and create it down here. So I'm going to create a function called add dot, and this add dot is going to have an internal and an external parameter. So remember we talked about internal and external parameters in Swift before? So the internal one is the one that you refer to inside the function, but the external one is the one that you use when you're calling the function. So the external one for add dot is at, and the internal one is the hit result. And then we have to specify a data type, which is going to be AR hit test result data type. So it's a little bit mad at me because I'm missing a bracket. So I'm going to hit Command A to select all, and I'm going to hit Option Control I to indent everything and make it look beautiful once more. Okay, so now I'm going to open a set of curly braces, and inside add dot, we are going to create a new dot geometry. So this dot is going to be a scene sphere. So just the same in the tutorial where we created the moon, we're going to create a 3D sphere. So I'm going to give this to you as a challenge and see if you remember how we created these geometries in previous tutorials. So you're going to be creating something called a dot geometry, and it is going to be a scene sphere, so a 3D sphere. I'm not sure you can have non-3D spheres. And the material of that sphere is simply going to be a red UI color. And then you're going to create a dot node that has the geometry of this newly created dot geometry. So pause the video, give that a go, and see if you can remember how we created 3D spheres in ARKit. All right, so let's go ahead and do that. So we said we're going to call it dot geometry, and it is going to be a scene sphere, and we're going to create it with a radius of, I mean, it's really up to you how big you want it, but I'm actually going to make it quite small. So 0.5 centimeter thereabouts should do just fine. So we're creating a new scene sphere that's about 0.5 centimeter in radius, so about 1 centimeter in diameter. And then we're going to create a material for it. So let material equal SCN material. And let's define the materials diffuse dot contents. That is going to consist of a UI color, that is a red color, as we said. And then I'm going to assign this material to my dot geometry. So dot geometry dot materials equals an array of materials that only contains our single red color material. Okay, so, and then we said we're going to create a node called dot node that was going to be a scene node, and it was going to be created using our dot geometry. All right, and that's it. So how was that? So if that was confusing at all, have a look back at the lesson where we created the moon and we created spheres and 3D objects in ARKit to refresh your memory. Okay, so let's go on to the next part, and it's, you guessed it, another challenge. So what I want you to do is to assign the position of this dot node using the hit result that we passed in here. So over here, we first detected any touches on the 2D iPad or iPhone screen, and then we converted those 2D coordinates into 3D coordinates by performing a hit test on the scene using that location. Now the hit test is going to look for any feature points that match up with a 3D continuous surface, so say a table or your laptop, and then we grabbed the first object in that array of hit test results, and then we passed that location in 3D called hit result into this add dot method that we're creating right now. So now that location is contained inside this internal parameter called hit result. So can you use this hit result to specify the position of our dot node in 3D? So it's a little bit similar to when we created the dice. We want to create this dot where we tap on the screen. So to do this, you're going to have to specify the dot node's position property. And it is going to be a scene vector 3, so it has an X, Y, and Z, and you're going to use the hit result to specify the position. So if you're up for the challenge, pause the video and give that a go. All right, so I hope that was okay. So as we said, we're going to specify the .node's position property. And as you can see here, it's expecting a scene vector 3. So a vector that has 3 components. So I'm going to use the scene vector 3 overload to create a new one. And if you scroll down here, there's one that says X, Y, and Z using ORCG floats, and that's what we're going to choose. Now inside these placeholders, I'm going to specify the X, so left and right, the Y, up and down, and Z, towards or away from us. So I'm going to use the hit result that we passed in here. And for the X, I'm just going to say hit result dot world transform dot columns dot 3 dot X. And then for the Y position, I'm going to say hit result dot, again, world transform dot columns dot 3 dot Y. And finally, I'm going to specify the Z. So hit result dot world transform columns dot 3 dot Z. All right, so all 3 dimensions are specified. So now it will know where to position our dot on the scene. And one final thing we need to do to add our dot node onto the scene is, of course, say scene view dot scene dot root node dot add child node, and the child is, of course, our brand new dot node. Okay, so let's go ahead and run it and see how it goes. All right, so that's the first part of creating our AR ruler. We're able to specify a location in the real world in 3D that we want to measure from and to. And we're able to put down this red dot to show on the scene where we want to start and where we want to end. So stay tuned, because in the next lesson, we're going to be taking these positions and working out the distance between the start and end points in order to actually have the functionality of an AR ruler. So I'll see you there.